First of all, I want to make sure that you know about the GitHub repository, github.com/Microsoft/reactors. That'll take you to our GitHub repo, and there you will find a folder called Online. And the two files that you'll need from there are Azure ML Studio, this one here. It's a Jupyter Notebook file, and you'll also need the Forest Fires CSV file. So first, what I'm going to do is I'm going to go to notebooks.azure.com. And I'm actually just going to go ahead and, if you want to follow along, you can use this file. I'm going to recreate it live for you. So I'm not going to use that, but I do have the CSV file already downloaded onto my machine. So I'm going to go to Azure Notebooks. Azure Notebooks is essentially Jupyter Notebooks, but in Azure, so it's in the browser for you. You don't have to install anything. All you have to do is log in. You don't need an Azure account. It's just a Microsoft account. So I'm going to go ahead and sign in. And since I'm already signed in to this browser, I don't need to put in my credentials. Or maybe I do. We'll see. Oh, I do. Okay. So since I haven't signed into this browser yet, I'm going to go ahead and put in my personal credentials here. Perfect. So now I've got Azure Notebooks opened, and I'm going to go over to my projects, and I'm going to create a new project. I'm going to call this one Azure ML Studio. And I'm going to go ahead and make it public. And we'll go ahead and let that load. In the meantime, I'm also going to go over to studio.azureml.net. And I should also plop in the notebooks.azure.com. And similarly here, you do not need an Azure subscription, only a Microsoft account, so I'm going to go ahead and sign in here as well. Basically, Azure ML Studio allows us to take whatever we're doing inside of our Azure Notebooks and put it up on a hosted place, so then that way we can access it even outside of our notebooks. All right, so today we're going to be using, like I said, the Fire Forest data. So I'm going to upload my Fire Forest data. And this Fire Forest data uses or has a few different features for it. It's got an x-axis, so we can actually take a look at this file, and a y-axis, which is a spatial coordinate in relation to the Montesino, oh my gosh, I'm going to totally butcher that name, park, which is a park, just a national park, and it's basically the location for which you're gathering this data. So that's our x and y. Month is the month of the year, 1 through 12, January through December. Day is the day of the week, 1 through 7, 1 being Sunday, 7 being Saturday. FFMC, this is where I went over to the Fire Weather Index to try to get a little bit more information. So let's go ahead and open this up and say FFMC. FFMC is the Fine Fuel Moisture Code. So it's basically all of the next few things: FFMC, DMC, Duff Moisture Code, DC, Drought Code, and then also ISI, Initial Spread Index. These all are basically ways in which they categorize forest fires. We're not going to actually worry about those too much during this stream, but if you want to learn more, this is a great site to kind of learn a little bit more about it. So those are those 1, 2, 3, 4 categories there. We also have temp, that's the temperature. That's going to be in Celsius, so between 2.2 and 33 degrees Celsius. RH, which is our relative humidity in percentage from 15% to 100%. Wind, which is our wind speed in kilometers per hour from 0.4 to 9.4. Rain, which is outside rain in millimeters from 0 to 6.4, and then area, the burned area for the forest. Notice that inside of this Azure Notebook or Jupyter Notebook file on the GitHub repo, you will have the features explained. So if you didn't kind of catch that right away, don't worry about it. It's all just right in here. All right. So now we know what our data is. And basically what we're going to try to do is we're going to try to predict the temperature given wind, rain, month, and relative humidity. So I'm going to create a new notebook, and I'll go ahead and call this one Forest Fire, and I'm going to use Python 2. And before we get started with the notebook, we need to make sure we are going to connect whatever we do in this notebook with our Azure Machine Learning Studio environment so that everything that we do in our notebook can be hosted elsewhere, and therefore you can connect to it and use the results of it and the machine learning with it outside of the notebook. So typically notebooks are used in a way where everything that you do is inside of the notebook, but that doesn't really make sense if we're trying to build a machine learning model and then use it for like an application, for example. Okay, so the first thing that we need to do is we need to import Azure ML. Preparing our container. All right. We're going to import Azure ML. Sorry, from Azure ML, we're going to import Workspace. And basically this will allow us to connect, again, this Azure Notebook with this Workspace inside of Azure Machine Learning Studio. All right. So again, similar to if you saw Christopher's stream last week, you never really want to share this stuff online, but I'm going to go ahead and delete all of this afterwards, after the stream, so I'm not going to worry about it too much. Number one, we need our Workspace ID. So that's, you're going to find under Settings, and it's going to say Workspace ID. And then next, you're going to need an authorization token. So that's under Settings again, and then there's going to be an auth token here. And then I'm basically going to create a variable inside of my Azure Notebook that will connect up this specific workspace on Azure ML Studio. So I'm going to call that WS, and I'm going to call this Workspace. I'm going to create essentially a workspace. Great. So let's make sure that that just worked. I'm going to run this. And we should, if this doesn't have any errors, this should connect up this Azure Notebook environment with our Azure ML Studio workspace. Great. Looks like it ran, no errors. I think we're good. Next, we're going to pull all of the data from our CSV file, that Forest Fires CSV file, out into a data frame, and then we're just going to plot temperature and area. So if you're using Azure Notebooks, things like matplotlib are already installed here, and so you don't have to worry about importing anything there. It just will work. So I'm going to import pandas. Specifically, I want to give it like a short name, PD. I'm going to create a data frame. If you haven't done any of this work before, I highly recommend watching some of our other streams, or we have them on YouTube videos at youtube.com/Microsoft Reactor. We'll put the link down in the below. Oh, it's already there. So there you go. So I'm going to read in the Forest Fires data into a data frame. And then I just want to plot, again, my temperature and versus area. Basically what I want to see is what I want to visualize is the area that was burned in relation to the temperature of that region or area. Okay? So we're going to specifically say that we want to have the graph show up in line. And we're going to create this plot. And these are all just some matplotlib things that you can use, all within notebooks and such. So I highly recommend just going and checking these out. I really want to get to the part where we connect it up to Azure ML, so I'm not going to go into detail with all of these. The data that I'm using for this graph is the data frame that I created. And I want some points and lines in there. So let's go ahead and run this. And this one's going to take a little bit. Oh, what did I do wrong? Forest fires, forgotten E. This one's going to take a little bit longer because it's actually going to go through that entire data frame and it's going to create this plot. You can see that it is working. It's trying to build this, these warnings. I'm not going to worry about them right now. One of my favorite things about working inside of notebooks, and especially using data science libraries that are like made for this type of data exploration, things like matplotlib, it allows us to start to explore our data without having to look at just this CSV file. If I were to just take a look at this CSV file and try to understand what was going on, it would be way too confusing. There's just like a ton of numbers. All of them are in different ranges. I don't know where to start to find trends. So by using some of these different libraries and by using something like Azure Notebooks or Jupyter Notebooks, by using something like Jupyter Notebooks, it allows us to explore in a more visual way. And then that allows us to determine where we do want to dive deeper and create new data or manipulate our data or clean our data. So again, we're not going to go into all of those pieces specifically. We're really going to focus just on creating that machine learning model and hosting it inside of Azure ML Studio. But we do have other videos to that effect. And if you go to our GitHub repo, we have other content around that as well. Takes a little while. There we go. Okay, so we can see that as the temperature rises, the area that was burned rises as well. Right? So in lower temperatures, we're not seeing as much, and then in higher temperatures, we're seeing more. That might help us indicate that temperature is what we want to predict. We want to know what temperature a specific area might get to, so then that way we know whether or not, or we know if we want to dedicate more resources to that particular area. So this will allow us, again, to see that temperature is the thing that we want to predict. Okay. So one thing that can be very useful is making sure that our data set doesn't only exist inside of our notebook. So right now our data set exists in this CSV file that's on my Azure Notebooks folder project, and it also exists in this data frame called DF. However, it would be very useful if this data set was able to exist outside of here, so that way if I needed to get rid of this project or something like that, it existed where my web service existed, which will be inside of Azure ML Studio. So what I'm going to do next is I'm going to transfer my data from Azure Notebooks into Azure ML Studio. Okay, so from Azure ML, I want to import data types ID, data type IDs, and I want to create a new data set that inside of my workspace, remember WS represents my workspace inside of Azure ML Studio, and I'm going to make this a little bit bigger. I want to go from into my workspace, go into my data sets, and I want to add from a data frame. So I want to add a data set from a data frame. That data frame is df. It's the one that we created above. The data type ID, basically I'm going to grab from the CSV file. So data type IDs, because this is a generic CSV file. So go ahead and just grab the data types from there. I want to name this, and I'm going to call this one Sarah's, we'll just call this forest fire data. And I do want to attribute where this data is coming from. This is not my data. I did not collect it. I don't own it. So I'm going to grab that copy and pasted from somewhere. This is actually the data collected by these folks back in 2007. All right. So we're creating a data set. So inside of our workspace, we have this data sets area here. I don't have any data sets in there right now. I want to create a data set from a data frame, and this is how I'm going to do it. So let's go ahead and run this. All right, and now over here, if we refresh our page in our Azure ML Studio, we should see that a new data set has been created. There it is, my forest fire data set. It was submitted by the Python SDK. There's my description. This is the data type. We've got all of the information right here. Awesome. Now, not only can we take something from Azure Notebooks and put it into Azure ML Studio, but we can also grab information from Azure ML Studio and bring it back into our notebooks, which can be useful if you might be doing something bigger and you might already have data up here and you want to start to play with it again over inside of notebooks. So in order to do that, for example, we can print on a new line. Where's my... all of the data sets inside of my workspace. So I'm going to grab all of the data sets inside of my workspace that are not example data sets, because we do have some example data sets that you can, that often is like, so we have some example projects inside of Azure ML Studio, and I think I deleted them when I was redoing all of this, but anyways, we have some example things. We don't want to grab those necessarily. We just want to grab the ones that are ours. So I'm going to go ahead and grab that, and you'll see that oops, sorry. You'll see that we've got only one data set in there right now, and it's the forest fire data. Awesome. So now we can see that we can take data from a CSV file inside of a Jupyter notebook, and we can put it into our workspace. And similarly, we can grab information from our workspace and bring it back into our Jupyter notebook. All right. So from now on, I want to use the data from the workspace, just so then that way I know where my data is, and that might be my cleanest data and the one that I want to track. So I'm going to create a second data frame that basically references that. So I'm going to get my data set from my workspace data sets. Specifically, I'm going to get the one called forest fire data. We can see that I've got a lot of information about the data sets from the workspace inside of Azure ML Studio. I can grab the name, I can grab the description, I can grab the family ID. In this case, like we're not getting too detailed into what all of the things that you can do inside of Azure ML Studio. It's really kind of this introduction between how they work together. But you can grab all of this information from inside of the notebooks. When it was created, oops, ds.created date, and also the size of it, which we have yet to explore other than just looking at the CSV file and scrolling. I noticed that someone is getting a cannot import name workspace. If you aren't working inside of Azure Notebooks, if you're trying this in Jupyter Notebooks on your local machine or Jupyter Notebooks inside of VS Code or any other thing other than going to notebooks.azure.com, you might need to install the Azure ML SDK. So you can look for information around that in the Azure Machine Learning SDK for Python. So that might be what you need to do in order to make sure that you have access to all of this. One of the reasons when I'm just kind of exploring for the first time, I like to just use the Azure notebooks because everything is just kind of ready and I don't have to think about it. And in this case, I don't even need an Azure account. I specifically just need to have a Microsoft account. All right. So let's go ahead and run this one and we'll be able to see the name, description, oops, I forgot DS here. The family ID, data type ID, created date, and size. And I can convert this into a data frame with a quick call to data frame. And I can check out that this looks exactly like the CSV file that I have over here. 753686.2, 753686.2. So we've got all the same data. Awesome. So now we're going to go into creating a model. So again, I'm not going to go into the details of machine learning here, but I'll kind of skim it a little bit. So we are going to use scikit-learn here. And specifically, we're going to use the ability to do the train test split of our data. So if you haven't done this before, I highly recommend checking out one of our previous videos or exploring our resources inside of our GitHub repo. But from scikit-learn model selection, I want to import train test split. So basically what I'm going to do is I'm going to take all of my data and I'm going to split my data between two sets, a training set and a testing set. The training set will essentially be run to say, like through my machine learning model to help my machine learning model come up with a sense of truth for what data will indicate a result. What I mean by that is if I want to predict temperature given wind, rain, month, and relative humidity, then I will take that information from my data set, from the training data set, and that'll be used to create the sense of like truth, basically the algorithm for which I'll run my test data through to see if I got it right. Okay, so we're going to split the data into two. Some of it is training data, some of it is testing data. Okay, so first I'm going to create this. This is essentially how it is always done using scikit-learn, specifically doing the train test split. So basically you can kind of copy and paste this and use it wherever you need to. So I'm going to call train test split. It's going to return to me basically I'm going to create four new variables: xtrain, xtest, ytrain, ytest. Xtrain will contain the wind, rain, month, and relative humidity. And ytrain will contain the temperature. And then similarly for xtest and ytest, but just for a portion of it that we're going to actually test to see how well our machine learning model accurately predicted temperature, or the y variable. So I want from my data frame, I want to grab wind, rain, month, and relative humidity. And what I want to predict is the column inside of my data frame, temperature. I want my test size to be 25%. So I want 75% of my data to be used to train my model, and I want to test 25% of it. And I want my random state to be 42. So this is just the random number generator that's going to randomly choose which rows to include in the training data and which rows to include in the testing data. You don't want to just choose the first 75% of your rows because your data might be sorted by something, either by just kind of first in kind of order, or it might be sorted by some other column. You want to make sure that you're avoiding any kind of sorting as much as possible. All right. So we'll go ahead and run this. And this is essentially just taking our data frame, splitting it 75% into our training data, 25% into our testing data in some kind of random fashion. All right. So now we're going to be running from scikit-learn the decision tree regressor. And again, I'm not going to go into this particular model. And we're also going to import a scoring algorithm to see how well we do. Okay, so we're going to create a regressor. This is another reason why using things like Azure Notebooks is great, because it already includes the scikit-learn library, and so it just makes it super easy. Again, I want this to do so randomly, regressor. I want to fit my training data. So my training data, I want to make sure that my regressor uses that data, X data, the wind, rain, month, and relative humidity, to predict the Y data, temperature. So I want to fit the data to make sure that that is always true. Given anything inside of X train, I will definitely get Y train. Then I'm going to actually predict the Y test values. So again, given the Y train, I want to predict the Y test values given the X test, okay? So I'm going to run predict on my regressor with X test. So this line right here essentially trains our model, and this line right here is to predict, basically testing our model, okay? And then we're basically going to print out the R2 score, seeing how accurate we actually were with our model, with our training data. And specifically, I want this to be floating point. And I want to format R2 score. So I'm going to score how well Y test from Y test predictions. Okay. So what's happening here? Y test, we know to be the truth for X test. Okay, so for every wind, rain, month, and relative humidity in X test, we have the answer for Y test. It's basically our answer key. Y test predict is basically the answer that our regressor gave us given X test. And so what we're doing is we're scoring how well Y test predictions, make sure it's actually just predict. Y test predict, we're scoring how well it did against the answer key. All right. So let's go ahead and run that and see how accurate we are. 63% accurate. So again, I'm not going into trying out other machine learning models or adjusting anything at this time, but I do highly recommend that you start to play with this. So when you are doing this on your own later, try different machine learning models, just try changing things up. Maybe try changing what your predictors are. Instead of wind, rain, month, and relative humidity, could you reduce those? Could you add something in there and try to increase your score from this 63? Okay, so in the last 15 minutes or so, I want to get into how to actually, now that we have something, I mean, it may not be the best, but we have something. We have this regressor that can predict temperature based on wind, rain, month, and relative humidity. And I want to make sure that anyone can use that regressor, pretending like I went through this and kind of got it to be the best accurate thing, without having to open up my Jupyter Notebook. Okay. So what I want to do is I want to publish this as a web service. So that's essentially over here. I want to publish this as a web service that can then be accessed either in Azure Notebooks again, or, and it could be this one or some other one, or in just kind of an app from anywhere. So from Azure ML, I'm going to import services. And I'm going to publish to this workspace using this authorization token. What I'm going to, the types that I'm going to take in for this web service are wind, which is a float, rain, which is also a float, month, which is an integer, remember that's just 1 through 12, and RH, which is also a float. And I want to return a float. That's going to be our temperature. All right. Then I want to create my web service. So this is basically the function that will be called when this web service is called. So forest fire predictor. I'm going to take in wind, rain, month, and RH. And I want to return, just kind of using my regressor, exactly what I did above. Remember when we did this above, we said predict X test. X test is basically wind, rain, month, and RH. And it'll return temp. Great. And then just for good measure, I want to save my service URL. So I'm going to grab that from my forest fire predictor. So then that way I can use this later. My API key. My help URL, in case we wanted to add any kind of documentation. And I've just realized I forgot service here. This is all a part of the service, not just a part of that function. And my service ID. Okay, so let's go ahead and run this and let's see if that creates the web service over inside of Azure ML Studio. Again, this web service should basically be running this function, which takes in wind, rain, month, and relative humidity, and then running it through the regressor's predict function, which will return to us the float for temperature. I did want to mention here is some more information about the decision tree regressor. But again, you should try out different machine learning models and see if you can make it more accurate. Still running. Hopefully I didn't have any typos anywhere. Oh no, I did have a typo. That's annoying. Let's try rerunning it. Stop. Try rerunning it. Make sure I didn't have any typos again. Workspace ID, authorization token. My wind is float, rain is float, month is integer, relative humidity is float. I'm going to return a float, creating the forest fire predictor with wind, rain, month, and RH, predicting and then grabbing my service URL, API key, help URL, and service ID. You can do it. I'm like hoping it didn't get stuck into some like weird state because of that error. See if anything else is happening over here. Nope. I'm getting paranoid. I don't think it took this long last time. I'm gonna copy this and I'm gonna cut it, and I'm just gonna run it over out of here. See if that works. Oh, why are you not running? You know, let me try changing this. Just in case, I feel like that error might have, or that typo might have gotten me into some weird state that made it wrong. There we go. I was gonna say that doesn't normally take so long. So then let's come back over here and let the web services refresh, and we should see our Forest Fire Predict web service. The neat thing here is that we can just call it from inside of our notebook. So remember, we already have access to our workspace, so we can just call Forest Fire Predict and send in and specifically call the service and send in some information. So wind, I'm going to go with 5.4, 0.2, 9, and 22.1. So I can run this and I will get Forest Fire Predict. And I should get, so this is now calling the web service with these values. I get 26.4. I can also test it out over here in Azure ML Studio. So I can click on that web service. It'll bring me to this dashboard, which has both a request response tester and a batch execution tester. So for example, I can jump into this test right here, which will bring me to this test web service kind of page. Once it loads, I will be able to do things. So I can put in my relative humidity, 22.1, my rain, which I think was 0.2, my wind, which was 5.4, and my month, which was September. And I can run through this and I get 26.4. And similarly, if I wanted to test this with batch execution, I could do that. This will require me to have like a bunch of data, obviously, a bunch of input, which I don't have. So, but you'll see in just a second that it allows you to bring up some files and test it. And finally, you can also just test this as you would in another application. So I'm going to create a JSON object basically of this same data. Okay, so I'm just going to copy and paste this because we're also just running out of time. So I'm going to import these libraries so that I can create some JSON in here. Same thing right here. Wind, rain, month, and relative humidity. These are my same values as before. So that's my data. I'm going to make my body be like a JSON dump of my data. My headers, basically I'm just going to grab, I'm going to copy and paste for quickness. I passed in my API key. Remember that we grabbed the API key up here earlier. And this is the request that I'm going to make. And then I'm going to have a try and accept in here. So basically I'm going to grab the response and load the result or throw an error. So we know, again, this is calling that specific one because we're using this API key right here. So let's go ahead, and also the service URL. That's the one that we are targeting. So we can go ahead and run this one as well, and you'll notice that we'll get 26.4. So that's 3 different ways that you can get that same information. One is by running it through, so first of all, you create the web service. You can just call it directly here. You can also test it out over inside of the testing page within Azure ML Studio, and you can also do it using JSON. Hi everyone, this is Sarah coming at you from post-streaming. We had a lot of technical difficulties on the stream this week, so if you're watching this on YouTube, that's why there's kind of an abrupt end. There will be a bunch of links down in the description below for you to try out this notebook on your own, and I highly encourage you to do so. Thanks for tuning in today. Have a great day.